Okay, let's dive right into this explainer. You know, if you're a developer working with React Native, you already know that adding camera features can sometimes feel like a massive headache. But today, we're taking a developer's journey straight into integrating high-performance barcode and QR scanning using the Vision Camera library. We're going to break down the exact steps to get this running perfectly. So, here is our roadmap for today. First, barcodes versus QR codes. Second, installing essential dependencies. Third, conquering native configurations. Fourth, accessing camera and permissions. And finally, number 5, scanning and processing frames. All right, section 1, barcodes versus QR codes. Now, before we write a single line of code or touch any configurations, we need to clearly define the actual targets we're trying to scan. There's a fundamental difference between standard barcodes and QR codes. A traditional barcode is strictly one-dimensional. It holds its information entirely horizontally. But a QR code, that's a two-dimensional matrix. It holds information both vertically and horizontally, which means it can store a vastly larger amount of data in a tiny, compact square. Section 2, installing essential dependencies. Let's grab our essential gear. You see, to build a truly robust scanner in React Native, we can't just rely on standard JavaScript. Under the hood, we really need two primary packages: React-Native-Vision Camera and React-Native Worklets-Core. Why these two specifically? Well, they're designed to tap right into industry-leading native tools. We're talking MLKit Vision for Android and Apple Vision for iOS. We're literally bridging top-tier native performance directly into our React Native environment. Following this exact workflow ensures your JavaScript environment is completely good to go. Step 1, run npm install React Native Vision Camera specifically at version 3.3.0. Step 2, grab React Native Worklets Core at version 0.2.2. And step 3, listen, you absolutely cannot skip this. You must add the React Native Worklets Core /plugin directly into your babel.config.js file. This is crucial to make sure all the heavy lifting we do later compiles correctly. Moving on to section 3, conquering native configurations. Right, so now we face the universal trial of mobile engineering, wrestling with native environments and permissions. Luckily, for iOS, it's actually pretty friendly. You just need a simple string addition in your info.plist file. Add the key ns-camera usage description and provide a string explaining exactly why the app needs camera access. Actually, without this, Apple will literally just crash your app the second you try to open the lens. Not fun. Now for Android, I really want you to pause and double-check your build.gradle file against this exact matrix, because native compiler errors are just the worst. Everything has to align perfectly. Your build tools version must be 33.0.0. Both your compile SDK version and target SDK version need to be at 33. Your minimum SDK version gets bumped up to 26, and your NDK version needs to be exactly 23.1.779620. Take the extra minute to get these numbers right, trust me. And as a final touch for Android, we get to do the always fun task of updating the Gradle wrapper. Just head to your Gradle-wrapper.properties file and make sure your distribution URL is pointing to version 7.5.1 or higher so you get a nice smooth build. Section 4, accessing camera and permissions. Okay, with the native gauntlet totally conquered, we get to jump back into the clean, modern world of React Native hooks. First up, we can't just forcefully turn the camera on. We use the useCamera permission hook to seamlessly handle our runtime security checks. It gives us a really handy Boolean called hasPermission to check the current status and a request permission function to trigger the native prompt for the user. It keeps our UI logic super clean. And grabbing the camera itself is incredibly effortless. By using the useCamera device hook, you literally just pass in the string back to target the physical back camera. Bam! Just like that, you've got the exact device object you need to start streaming video. Finally, section 5, scanning and processing frames. We have reached the victory stage, folks, actually capturing and processing those camera frames. To understand this, we have to talk about frame processors. By definition, these are functions that process the individual frames the camera sees in real time. They are the absolute magic of this setup. They let you call high-performance native functions for heavy tasks without bogging down your main JavaScript thread. So here is what it looks like in practice with the use frame processor hook. Notice that really critical worklet directive right at the top of the function. By wrapping a native object detection function in a worklet, we can analyze the video stream synchronously, literally frame by frame as it hits the lens. And when you pass that frame data through and ask for a simple log, seeing a message like detected 3 objects in your console is just the ultimate payoff. It proves your custom frame processor is doing its job, instantly identifying items out there in the physical world. Now, building custom frame processors is super powerful. But hey, if you just need standard code scanning out of the box, the useCodeScanner hook simplifies the whole shebang. You just pass an object to finding your target code types, like QR and EN13, and provide an on-code scanned callback to catch the data. Imagine the sheer satisfaction of triggering that callback when your app instantly recognizes multiple codes at once in the viewfinder. Your terminal lights up with "Scan 2 codes," handing you the raw barcode data right on a silver platter. The versatility of this library is just fantastic. Whether you're tracking massive warehouse inventories with code 128s, checking out retail products with standard EAN13s, or routing users via QR codes, this handles it all beautifully, using those native MLKit and Apple Vision engines. So, we've covered the concepts, the native setups, the hooks, and the massive potential of frame processing worklets. Now that you've got this setup mastered and hold the keys to real-time image analysis, I've got to ask, how are you going to unleash this scanning power in your next major React Native project? Think about it. Thanks for joining me for this explainer,